A local high school makes a change that should improve student satisfaction with the parking situation. Before the change, 37% of the school's students approve of the parking that was provided. After the change, the principal surveys an SRS of 200 of the over 2,500 students at the school. In all, 63 students say they approve of the new parking arrangement. The principal cites this as evidence that the change was effective. Perform a test of the principal's claim at the alpha equals 0.05 significance level. Okay, so before the change, 37% of school students approved of the parking, and they did some remodeling, right? And then the principal took a survey of 200, right? A sample of 200, and out of the 283 said that it was an improvement. So, first off, let's get that sample proportion, right? So that's going to be 83 over 200 is 0.415. So we can see why the principal is making this claim, because 37% of school students approved of the parking that was provided, right? But after he did this remodeling, it appears that 0.415, so about 41.5% of students thought that the new parking was better. So we can see why the principal is claiming that the new parking is better. But let's see if this is statistically significant or not, right? Using our hypothesis testing. So we want to perform a test at the alpha equals 0.05 significance level of, so this is the null hypothesis. So basically this is saying that there is no change after the parking situation was changed, right? So the population proportion is going to remain 0.37 versus, so the alternate hypothesis states that the proportion is going to be bigger than 0.37. So basically what the principal is claiming, right? Where P is the actual proportion of students who are satisfied with the parking situation. If conditions are met, we should do a one sample z-test for the population proportion P. Okay, so let's test our conditions. So the first condition is random. Okay, so this was an SRS, so the sample was randomly selected. All right, so now let's check our normal condition. Okay, so the expected number of successes so that's going to be n times p naught. So the number in the sample was 200. Our null hypothesis proportion is 0.37. And then this is going to be 74, which is, of course, bigger than or equal to 10. So that passes. And then n times 1 minus p naught, which is 200 times 0.63, which happens to be 126, which is, of course, bigger than or equal to 10. So our normal condition is satisfied. Now let's do our independent condition. So independent. And of course, this is also known as our 10% condition. All right. So remember, n was 200. So this is the inequality we need. N is less than or equal to 1/10 of big N. So the number in the sample was 200, which is less than or equal to 1/10 of the number in the total population, which was 200 or 2,500, right? A tenth of 2,500. So a tenth of 2,500 is 250. And of course, 250 is bigger than or equal to 200. So our independent condition is satisfied. So all conditions are met. All right, so now let's start our do. So, of course, our sample proportion, remember, our sample proportion was 83 over 200, which was 0.415. And the corresponding statistic is, so this is Z is equal to the statistic minus the parameter all over the standard error of the statistic. All right, and this is equal to, so our statistic is the one we're testing, our p hat minus our null hypothesis proportion, right? Our parameter, over the standard error of the statistic. So this is the square root of p naught times 1 minus p naught, all over n. So remember, p hat was 0.415. Our null was 0.37 over the square root of 0.37 times 0.63 all over 200. And that gives me a statistic, a z statistic of 1.32. So because we're trying to find our alternate hypothesis is our proportion is bigger than 0.37, we're going to have a one-sided test, right? So since this is a one-sided test, the p-value is, so the p-value is going to be the probability that z is bigger than 1.32, which of course is the same thing as 1 minus the probability that z is less than or equal to 1.32. And then we go into our table to find that 1.32. Okay, so 1 point, my highlighter, 1.3, so 1.32, so that's this guy here. So 0.9066. So let me go back, which is equal to 1 minus 0.9066, which is equal to 0.0934. All right, so this is our conclusion if we get that p-value to be 0.0934. Since our p-value is not less than alpha, which is 0.05, right? Since we got 0.09, right? We have to fail to reject the null hypothesis. So tough break on the principal, right? He just didn't make a large enough survey or a large enough sample. We do not have enough evidence to conclude that the parking arrangement increased student satisfaction with parking at this school. Okay, so the objective to accept the alternate hypothesis is to get this significance level, or to get that p-value to be less than that significance level. That is the objective, to say that the alternate hypothesis is true.